Hello friends. So today we'll see the next question in LeetCode 75 series. Yesterday we completed two-pointer approach, like questions in two-pointer approach in LeetCode 75 series. Now we'll see the first question in sliding window. So let's go to the question. Let me take you the question. Yeah. Now. Okay. So yesterday we completed last question, that is string compression, and not of string compression, sorry, max number in k sum pairs. This we completed, and today we'll see the maximum average sum subarray 1. And yeah, let's see what is the question. What the question is, okay, it is a 643th number question, maximum average subarray I. And question, you are given an integer array nums consisting of n elements and an integer k. Okay, find a contiguous subarray whose length is equal to k. Some like contiguous subarray whose length is equal to k that has maximum average value, and return this value. Any answer with the calculations error less than 10 raised to minus will be accepted. Okay, so what does this saying? We want to return the maximum average of the elements, and the elements should be the from the subarray of length k from the given array. So for that we need to do sum. We need the sum of k elements, right? So as they have said ki it is contiguous subarray whose length is equal to k, and that's the maximum average. So average, what I'm trying to get is we need sum, so we can use prefix sum here, that at the ith point I will get the ith sum, and we just require k elements, that from previous k, like from I minus k to I, that will be the k element, and we required only that sum. So sum I minus k minus sum I minus sum I minus k, it will give us the sum of the k element in that subarray, and we'll divide it by k to get the average, and that will work, that it will give us an average, and we'll store the maximum average till the end. And yeah, that's my first approach. That, let me write it. What I was saying, ki I was saying, uh, use prefix sum, and prefix sum is basically we add the element till that index, like from 0 to I. I is any index 1 to 0. It's from 0 to n. N is the size of the array, and in prefix sum at ith index we'll get the sum from 0 to that ith index. So we'll use the prefix sum, we'll store the sum, and to get the sum of k elements, we just simply, what we can do, get the sum that index, and subtract sum I minus k, so that this sum will be the sum of k elements, and divide the whole thing by k. And itself, like prefix array, make the prefix array as double, and so that when we divide it by k, the answer will be in double, and we don't need to convert it again and again. That's what I wanted to say, and this will be my first approach. So for that, I am storing every sum for that every index, that is a prefix sum. So it taking size, like it's taking memory, and the space complexity for this will be big of n, and time complexity will be also big of n. Like first I will calculate, that will be the first pass, n in log big of n. Then I'll calculate from I minus I minus k, like I will start I is equals to k, and till I is less than n. Then I'll get the sum by sum I minus k, and I'll divide it by k, and I'll store that average, and I'll store in answer that what is the maximum average. So overall this taking big of n, we can see it is n minus k, but what if k is 1? Then ultimately it is taking big of n time. So time complexity will be big of n. Like first big of n, it took the first big of n to calculate the sum. Then again big of n minus k, that ultimately the time complexity will be big of n. N is the size of the element, size of the array. And now at this point, we I will think what we can do about the size. Like what about the memory? Sorry, without using an extra database, can we solve it? Yes, we can solve it. That is the part of the, like that is the intuition of the square. Like that's the uh, part that we'll learn from this question, that without using the extra space, using the use of sliding window in such questions. So how we can use a sliding window in such question, that we'll use two pointers first, left and right pointer. Till my right pointer get till reach k, we'll sum it. And after that, like till the k, I'm reaching at k, then I'll store the that average. Then my right is less than n. At that point, I'll shift my left pointer and my right pointer, left pointer, right pointer, left pointer with the size k. That is, the window size will be the k, and the two pointers will be left and right pointer. So yeah, we'll see how we can do that. And for this, the time complexity will be calculated. But let me write first code. What I said. Ki, let's take a two pointer first. Let l is equal to 0 and r is equal to 0. The difference between r minus l we'll take the average when the r minus l will be k, because they have said we want k elements, like subarray with size k only. So our sliding window size will be the k. So while let's take first size also, n is equal to nums dot size, and we'll store the sum in double, so that we'll conversion will we are avoiding conversion at the time of uh, making it like taking the average. So I'm declaring sum is equals to k, and while my r is less than k, like to the I'm taking it to the taking window like r till k. I'm adding it to the sum plus equal to nums at k, nums at I r, sorry. And then my answer is also double. So my answer for this will be sum by k. Let me check this sum is 0, like k is equal to 0 or not. Okay, they have given k will always greater than 1. So yeah, k won't 0. So yeah, we can take it less sum by k. And now what we'll do, while my r is less than n, what I want to add the next element, and I want to delete the last, like delete all the, subtract the last element in the sense, the element or the number which is out of that size k window. So for this, we'll add at rth element, and I forgot to enter this r. So yeah, this will go in infinite loop. So now it's fine. And now we'll subtract it from sum, that nums at l. So basically we took the sum of k elements only, cause we subtract the nums at l. Now increase it r plus plus and l plus plus, or we can itself here also increase it, that take the nums r and increase it, takes the num l and increase it, that we shifting to the next element. And now my answer will be we want maximum answer, so maximum of answer and sum by k. So that how we'll store the answer, and we'll return this return answer. Yeah, so let's run it. It's accepted. Let's submit it. Yeah, it is accepted. So for this, we are not using prefix array like how we used here. So for this, the space complexity will be big of 1, because we are just using these variables to store the to store the left and right pointer and to store the sum. So time say space complexity for this will be big of 1, that is the constant space complexity, and for time complexity for this will be big of n, cause we are just in one pass only we are doing it, cause till we get r k sorry my r is less than k, till I'm adding it to the sum, and then when till my r is less than n, I'm adding it to the sum and making the operation that sum answer is equal to sum by k, they're taking the average. So for all this the time complexity will be big of n only, and yeah, that's the efficient approach. And yeah, we'll see the next question in next video. For that, yeah, now bye.